been working on. We know that hand trick, we've been filling out the table. We might try to take a few minutes at the end of class today and try filling out that table again. And we've also, back in chapter 1, talked about when the trig functions were positive or negative. So we are going to put those two things together today and start finding some trig function values at non-acute angles. So if I said sine of 150 degrees, what would that equal? Now my goal is not for you to have to memorize 9 more common angles. Okay, we're going to take what we already know and extend that. First thing that we will be doing is talking about a reference angle. So anytime I say reference angle, it is the positive angle between the terminal side of the angle and the x-axis. I'll let you write that down and I'll explain what that means. Notation for reference angle, we typically call it a theta with a tick mark next to it. Represents reference angle. Remember, if an angle is in standard position, your vertex is at the origin, your initial side is the positive x-axis, and then your terminal side is anywhere else. So if this were my angle, the reference angle is from the terminal side to the x-axis. So my reference angle would be over here. Reference angle always goes to the x-axis, never the y. So what we're going to practice first is we're going to look at an angle and try to find the reference angle. After we do this quite a bit, it's going to become kind of second nature to you, but in explaining it, a lot of times I'm going to draw a picture. You do not have to draw a picture when they ask you to find a reference angle. This is just if it helps you. Okay? So here is my first one, 30 degrees. I want the reference angle. So this is actually kind of a trick question. So this other side is 150, but the reference angle is just to the x-axis. So in this case, if your angle is already acute, your reference angle is the same as your angle. So if it's in the first quadrant, if it's between 0 and 90, the distance to the x-axis is the same thing. So that's why we haven't really been using reference angles so far, because everything we've looked at has been in the first quadrant. B though, if I said 135 degrees, what quadrant is 135 in? Second. So if this is 135, my reference angle is the distance to the x-axis, so that would be over here. How do we get that? We know this whole thing would be 180. So you can do 180 minus 135. So your reference angle is 45. Your reference angle is always going to be an acute angle. So it'll be some number between 0 and 90 every time. C, 240. So 240 degrees would be in what quadrant? Third. So this whole thing is 240. What we are interested in, reference angle is just the distance to the x-axis. So what do we have to do? From here to here is 180, right? So if I subtracted off that 180, then it would be 60 degrees. So here is 180, then to keep going down here, you'd have to have an additional 60 degrees. 330 is in what quadrant? So if we drew that, this is my angle. Where's the reference angle? It's just distance to the x-axis, so that's right here. You know, if you go all the way around, how far is that? So you could do 360 minus the 330, and our reference angle is 30 degrees. You notice we're basically subtracting every time. We're either using 180 or 360 because those are the measurements on the x-axis. We are never measuring distance to the y, so we're never using 90 or 270. 210 degrees. What quadrant is that? Third. So if this is 210, reference angle is just the distance to the x-axis, so what would you have to do? Is on what quadrant? Second. So we know from here to here is 140. So how do we get the distance to the x-axis? So it would be 40 degrees. Your reference angle is always positive. So if you accidentally did 140 minus 180, you would get a negative, and you know that's wrong. So it's always a positive number between 0 and 90. All right, so really our strategy for finding the reference angle depended on which quadrant we were in. In the first quadrant, your angle was already between 0 and 90, so did we have to do anything? No. So in quadrant 1, the reference angle is the same as your regular angle. When we were in quadrant 2, so if we look at our examples, we are in quadrant 2 on example B and F. What did we do there? So in quadrant 2, your reference angle is 180 minus your regular angle. In quadrant 3. So we are in quadrant 3 and I'm seeing examples C and E. What did we do there? The angle was bigger than 180 to start with, so we had to do the angle minus 180. When we were in quadrant 4, so that was example D, what did we do? So this isn't necessarily like you have to go home and study what to do in each quadrant. We figured it out on the previous slide without having these rules. I'm just kind of generalizing how we got to each piece. Are there any questions there? So what we're going to do now is if I ask you to find the trig function of a non-acute angle, we are actually going to evaluate it at the reference angle. So it turns out, when our reference angle is 45 degrees, all the trig functions are equal to the same thing as when we have a regular 45 degree angle. The only difference would be, depending on your quadrant, what do we have to watch? Negatives and positives. So these answers are going to be the same as we did with our hand trick, but we'll have to watch the quadrant to decide if we need to be positive or negative. So let's look at an example. So I want the exact value of each. So exact value means no decimals. You have to give it to me in radicals. When I ask you to do these problems, I'm going to want you to write down two things first. So this will really be your work. You'll get points for telling me the quadrant and the reference angle. So 240 is in what quadrant? Third. How would you find your reference angle? And that gives us 60.
That's all we do,
Well, now we have to evaluate it. So, in quadrant 3, remember all students take calculus. We're talking about sine. Will sine be positive or negative in quadrant 3? Negative. And then we just have to do the sine of 60 degrees. So think about our hand trick. Hold in your ring finger, that's your 60. Sine is the square root of the top over 2. So it's negative radical 3 over 2. And that's our final answer.
Oh, you just did sine of 60 degrees.
And the quadrant 3 is what made it negative, so we just knew it was going to be a negative sine of 60. And the sine of 60, like from our table that we've been doing.
So when we do the reference angle, is it going to be always like what we did on the charts?
Yes, if I'm asking you to give me an exact value, your reference angle will turn out to be 30, 45, or 60 every time. Is that one okay? So B, tangent of 315 degrees. What quadrant is 315 degrees in? How do we get our reference angle? 360 minus 315 is 45. In quadrant 4, is tangent positive or negative? Negative. So really all we're going to have is a negative, whatever the tangent of 45 degrees is. So at 45, tangent is square root of the top over square root of the bottom, so radical 2 over radical 2 is 1, so negative 1. Cosecant of 300 degrees. What quadrant is 300 in? Quadrant 4. Reference angle, what do we do? 60 degrees. Okay. Sometimes people struggle a little more with the reciprocals, cotangent, secant, cosecant. If you need to, we could just think about its reciprocal for a second. What is the reciprocal of cosecant? Sine. Okay. In quadrant 4, is sine positive or negative? Negative. So my answer is negative. What is the sine of 60 degrees? Square root of 3 over 2. So to get cosecant, you flip that. So it'd be 2 over radical 3, so negative 2 radical 3 over 3.
And we'll have to remember those, like the stuff like a test or something.
Yeah, so what I'm going to do when it comes time for the test on this is the first page of your test is actually going to be just a blank table. And I'm actually going to have you guys fill that out first, and then I will come around and grade it before you do the rest of your test. So that way, if you messed up one of them, you don't mess up on the entire test. So you'll know, and then you'll have the right values for the rest of the time. So this is really all we're doing. We're just going to keep practicing with these. What if I asked you to find all 6 trig functions for 585 degrees? What would we need to do with that? Yeah. We can find coterminals. If I give you a negative angle, then you know you have to add 360. If I give you a really big angle, you know you need to start subtracting 360. So when you subtract 360 from this, we get 225 degrees. All right, what quadrant is 225 in? Third. It's between 180 and 270. Reference angle, what would we do?
225.
45. All right, so I want all 6 trig functions. In quadrant 3, what's positive? Tangent, and so cotangent would be positive. So that means the other 4 are negative. Okay. So now we just need to evaluate all these at 45 degrees. So what's the sine of 45 degrees? What's the cosine of 45? Tangent. Radical 2 over radical 2, which is 1. And then for the others, we just do reciprocals. So if I did the reciprocal of negative radical 2 over 2, you have to get the radical off the bottom. And those 2's drop, so we just get a negative radical 2. So secant would also be same thing, and cotangent would be same thing as tangent. So far, so good? Let's do a problem like this. We've done some with all acute angles before. We had some in the last section. So we just have to go through and evaluate each of these pieces. When it says sine squared 45 degrees. Sorry, do you want me to let you write that down before I talk? So this means we have to do the sine of 45 degrees and then square it. Now 45 degrees is in quadrant 1, so we don't even need the reference angle. We just have to evaluate it. What is the sine of 45? Radical 2 over 2. Cosine squared of 135. What quadrant is 135 in? 2. Reference angle, what would you do? 180 minus 135 is 45. In quadrant 2, is cosine positive or negative? Negative. Cosine of 45 is 2 times the tangent of 225. What quadrant is 225 in? Reference angle. What would we do? 225 minus 180, which is 45. In the third quadrant, is tangent positive or negative? Positive. And tangent of 45 is 1. So now we just have to evaluate this. Radical 2 over 2 squared would give you 2/4, or 1/2, plus 3. Negative radical 2/2 squared would be a positive 2/4. Is 1/2. Times minus 2. So we get 2 minus 2, which is 0. So I could ask you to just evaluate some of these expressions, and all you're doing is plugging in the value for each angle. So far, so good? Okay. Last example. I'm going to kind of switch it up. Find all values of theta in the interval 0 to 360, where the following is true, that sine of theta is equal to negative radical 3/2. Alright. So we're thinking in reverse here. I know that sine is a negative number. So can you tell me what quadrants you could be in? 3 and 4. So we should have 2 answers here. One for quadrant 3, one for quadrant 4. And again, that's because this was equal to a negative number. Reference angle. Can you tell me when sine is equal to a radical 3/2? Sine of 30 is 1/2, 45 is radical 2/2, 60 is radical 3/2. Okay. So, what that means in quadrant 3, if this little angle were 60 degrees, what would the whole thing be? Yeah, you'd have to do 180 plus 60, so that's 240 degrees. In quadrant 4, if this angle were 60, what would this whole thing be? 300. And that's our final answer.
I thought that was going to be a lot harder than what it was.
Good. Glad it wasn't. Oh, can I change something on B? Because this problem doesn't work. Can we say secant is equal to 2? So I got that. Okay, typically we are less familiar with secant, cosecant, and cotangent. So if I tell you secant is 2, what does that mean? Cosine 1/2. Okay. So cosine is positive. When is cosine positive? Reference angle. When is cosine 1/2? Think about the hand. Cosine is the bottom, so at 30 it's radical 3/2. 45 it's radical 2/2. At 60 it's radical 1/2, which is 1/2. So it's at 60 degrees. So in quadrant 1, what would my angle be? Yeah, remember in quadrant 1, your reference angle and your angle is the same.
I was about to say, I got confused because I said quadrant 1 and I did a dash mark, so I thought it was subtracted.
Oh.
1 minus whatever, that makes no sense.
In quadrant 4, if this is 60, what would that be? 300. Do 360 minus 60. All right. Questions there? Okay. So next thing I want you to do, get out one of your many blank tables. You should still have a couple left.